Welcome back, my friends. You may recognize this handsome young man right here. He's been in a video with me already. We talked about this machine where there's only two in the world. We talked about some processes of riveting that can be extremely complicated, multiple materials diving through. I am a speeds and feeds guy, so I had to do a separate interview to learn more, and I think there's a lot of folks out there just like me that want to learn more as well. So, Michael, we're here today. We got it all set up. We're looking at this piece right here with a lot of different materials in there.
Correct.
How does this all work?
Well, so this is actually an example of a complex application for aerospace final assembly where they're putting components together and they're having to drill through the different layers to join the materials together with rivets or whatever fasteners that they're going to use. In this example, we had to drill with one tool through CFRP, 4 separate layers of titanium and exiting in aluminum, all while still meeting the customer's requirements for bore diameter, interlaminar burr, exit burr, and surface finish.
In my machining experience, that's a no thank you. I'm not sure if I can do that.
Well, and then the additional challenge is that with the drill motors that they were using, their ADUs were pneumatic, so you have a fixed feed and speed. So now, instead of transitioning with feeds and speeds through the different materials, you have to choose a fixed feed and speed to accomplish your goals.
With a single tool?
With a single tool.
Through all that material?
Yep.
And different materials?
Correct.
And no burrs?
Right.
Sounds fun.
Yeah, it's fun. And then on top of that, we had the request to have one tool per aircraft, which was just over 100 holes. So the tool had to meet all the requirements for over 100 holes.
Right, we're not just talking about, well, that tool worked once really
Right.
well. That was fantastic.
Right.
We got through the job. Now it needs to make sure to get through lots of holes.
Right, correct.
All right, well, we got a screen right here. I know you want to talk a little bit more about this. This kind of confirms the idea of what's happening physically here. We can see the different variations on the screen.
Correct, yes. So in this case, we have the force in newtons over time. And you can see this is in the CFRP material with the same feed and speed as the rest of the stack. First layer titanium, second layer titanium, third layer titanium, fourth layer into the aluminum and exiting the workpiece. And here you can see the torque calculation. The torque calculation typically mirrors the cutting forces. This is the thrust force, by the way, the Z-axis force.
The top one is the thrust.
This is the thrust force.
Now we're talking torque.
This is torque.
Okay.
Right? Now, what we might see is after we get past 100 holes, for example, maybe the titanium is starting to work hardening, some work hardening happening. We will see the torque increase the deeper you go into the hole because it's starting to squeeze onto the diameter.
Of course, yeah.
So that also helps us fine tune the tool, to meet the goals of the customer as far as tool life goes.
It's amazing what can be done on the software side of things these days, Michael. I tell you,
Yeah.
I used to have to go by vibration and noise.
Yeah.
I got to hear a machine and go, something's wrong, or that one's humming like it's supposed to. But this gets us to that 10 parts to 100 parts, and maybe even more in the future, right? By understanding this algorithm.
Right. Absolutely.
Amazing, absolutely amazing. I hope you guys found it as fascinating as I did. We had to do a piece just on this. Again, this machine, there's only 2 in the world. This guy, there's only 1 in the world. So if you put the 2 together, it's quite a special project. And, I mean, are you kidding me right now? What a difficult process that's actually starting to be solved in a really high nature thanks to people at Mapal. Michael, amazing, absolutely amazing. Thank you.
Not a problem.
You have answered a few of my questions, but like always, now I got a million more. We're not gonna do it on camera this time, but thank you so much for doing that right now.
Absolutely.